Hello, everyone. Welcome to today's webinar, the third webinar in our TritonGPT series. And today's webinar is called Blueprint Revealed inside TritonGPT. And we're really looking forward to presenting with you all some of the kind of more technical aspects of TritonGPT. And I'm really excited to be joined with some of my colleagues from ITS to talk to you all through the hard work that they've been doing for the last 12 to 18 months. So my name is Stephen Savini. I'm a senior analyst at UC San Diego's Operational Strategic Initiatives, and OSI has been really happy to partner with ITS on kind of the business side of TritonGPT, and this is one of the products that's come out of it. So I'm going to go into our goals for today. So our first goal is to introduce UC San Diego's approach to AI, including some of the infrastructure, the technical components, as well as our business strategy with developing our own AI tool, TritonGPT. And it's something that's really rare within the higher ed industry, and it's really groundbreaking work that we're doing. We want to talk through how TritonGPT is interacting with different UCSD knowledge bases in order to kind of reshape the way that employees are interacting with training and knowledge content at UC San Diego in order to create an AI tool that is unique to us. We want to let you all know about what assistants are currently within the tool, as well as some really exciting projects that are coming through the pipeline that will provide even more functionality for our staff and faculty. Then we'll touch a bit about AI safety and talk through how we're developing TritonGPT in a safe manner. And then lastly, highlight how AI ideas are being reviewed and stewarded through the development process to ensure that each area of UCSD is benefiting kind of equally as much as possible from this increase or this kind of new AI technologies that have hit the world. Before I hand it over, just really want to quickly call out to the fact that some of this information is going to be a little bit more advanced, a little bit more technical. For some of you folks on the webinar who aren't as geared into that tech world as some of our presenters, myself included, just want to let you know that some of this might be a little bit complex, and that's totally okay. I think one of the points that we wanted to put on by having this webinar is that TritonGPT and these new AI tools, it's not just magic, not just something that appeared out of nowhere and we're using it. The TritonGPT and these other tools have been really a product, or sorry, TritonGPT specifically has been a product of a lot of really hard work by not just the individuals who are presenting with me on this call, but their teams and other collaborative partners within the space. There's a lot of really great work that's being done, and we want to highlight not just the fact that not just all of the the fact that we have TritonGPT, we also want to highlight all the hard work that's going on behind the scenes. So with that said, I'm going to do one more slide actually of table setting. So we have about 60 minutes of content prepared for you all today. And then after that, we're going to do kind of an open Q&A. So if you have any questions, please put it into the Q&A section at the bottom of your screen. We have a few other allies who are answering questions in chat, as well as they'll kind of be indicating when we want to answer some of these questions live. And then at the very end, we'll kind of do a live Q&A as well. We are recording. I am pretty sure we are. Yes, we are recording. I see the button. Thank you, Tony. We are recording, and so we'll send a link to the recording out to everyone who registered for the webinar, as well as the slides. As we also be sharing the slide deck as well, and we'll also talk through at the very end kind of a TritonGPT resource page. So all this information, all the recording and the slides and all that, it'll be on that Blink page as well. So without further ado, I'm going to hand it over to Sean Monroe.
Hey everybody, Sean Monroe. I'm Service Offering Manager for TritonGPT, in addition to several other responsibilities I have at the campus. But kick it off for you all today about the behind the scenes from TritonGPT. We're going to start pretty high level. We'll go into a lot of detail, and we'll come back out high level, kind of summarize everything that we kind of went over today, and give you some good nuggets of opportunity for you to be involved in different aspects of TritonGPT going forward. So I wanted to start it off with this slide, just kind of talk about vertical versus horizontal AI. And where this really comes into play is horizontal AI is very wide. So it's these large language models that have been trained with a lot of general information and, billions of different aspects of data is going into training these models. So they have a lot of information. They're really great with helping generate ideas and helping do different language work you would want to do in the general generative AI work. But what we're looking to do with Triton GPT is still have some of those pieces available. We do have large language models where you could interact directly with the one of some of the industry leading large language models. But we're also focusing on this idea of vertical AI. So we're looking to focus in on UC San Diego content in Triton GPT so you get relevant information when you're working with these large language models. Quick example I like to give about that is I work for a portion of UC San Diego called ITS that we refer to ourselves as. If you go to, you know, ChatGPT or any of the other big models and you say, what is ITS? What do they do? Who are they? It's going to give you a lot of different options of who ITS are and what they do. International Trucking Systems is one that happens to come up a lot. Right, not exactly what I do here at UC San Diego or the organization I'm involved with. But if you go to Triton GPT and you use the UC San Diego assistant, you say, who is ITS? What do they do? It's going to give you relevant information about information technology services here on campus, how to reach us, some information about us, and it's going to reference content from UC San Diego specific to ITS. So that's kind of the idea behind the horizontal AI and really some of the focusing we're trying to do with different assistants on the Triton GPT platform. So that's the high level. I'm going to turn it over in the next slide to Matthew, who I'll let introduce himself, and he'll give you a bit more on how that works and how we're making that happen here at UC San Diego.
Thanks, Sean. Hi, everyone. My name is Matthew Holland. I'm a developer at the ITS AI platform. And today I'm just going to kind of start out with RAG at a high level. So RAG stands for Retrieval Augmented Generation. It's a technique that allows for large language models to access information related to a user's query and use that information as part of its response. And this is useful because out of the box, although large language models have been trained on a vast quantity of information from the web mainly, their knowledge is fixed to the time of training, right? So if you've probably, if you've used ChatGPT, you might have noticed like the cutoff date, I believe, is December 2023. And so in a lot of cases, that just isn't good enough, right? And so RAG allows us to search through newer, more up-to-date documents, as well as kind of what Sean talked about, specific documents to an enterprise or organization that the large language model was never trained on. Next slide. So there are two main parts of RAG, the index process and the query process. Starting out on the index process side, we'll take a look at the bottom there, the raw data sources. So here's where we, take a collection of data that we want to pull into our database, whether that's, PDFs based off policy, different text files, videos, websites, and we convert them into text form. And so that usually involves, scraping, extracting text, transcribing video. The next step is the contextual annotation step. This is where you might want to add additional metadata to your existing data. For example, when was this data retrieved? How up to date is this data? Does this data belong to a specific grouping of documents, that sort of thing? And then we chunk up the text into smaller, more manageable sections. Because large language models have a limited amount of information that they can process at a time, this chunking step allows us to break what could be huge documents into smaller, manageable chunks to be returned during search. Next up, we have an embedding model that converts these chunks into high-dimensional vectors that represent the text meaning. And these high-dimensional vectors are then stored in a vector database. So now that we're kind of in the query process step, we can start out in the top right. We have a user query that comes in. that user query is then also encoded using the same embedding model into a set of high-dimensional vectors. And we can use something like a common form of similarity search, for example, cosine similarity between vectors, to actually determine what the most similar chunks of text that we have that relate to the user query. And so then once we're able to score these documents and find kind of the most similar relevant data, we're able to provide those most relevant documents back to the large language model along with the original user query. And the large language model is then able to reference these documents and use these documents as part of its response. Next slide. So just to kind of summarize, why does RAG work so well? RAG takes into account the meaning of the user's query to retrieve related documents versus something like a traditional keyword search, where instead of searching against meaning, you're searching against, does this text match? And so that's not as good of a search method in the specific use case. Another reason why RAG works so well, it allows models to access a lot of data while working within its limited context window. For example, with TritonGPT, we've indexed, tens of thousands of documents, and that just wouldn't be possible with the kind of a traditional, traditional kind of methods. We also reduce hallucination by not needing to rely on the LLM's based training data set, that OpenAI or Meta or Claude has generated. We can actually use content that we've curated ourselves. And next up, I'm just going to pass it to Adam to talk about how RAG is used specifically within TritonGPT.
All right. Thanks, Matthew. Hi, everyone. I'm Adam Tillman. I'm the principal architect for our AI infrastructure and service owner of our data science machine learning operations here at UC San Diego. And to carry on from what Matthew was saying earlier, I just want to walk you through what a request coming into TritonGPT would look like inside the system. And I'm going to start with a query, which actually has nothing to do with UC San Diego, asking what is Dancer? And I'll ask that question and I'll actually answer it right now. Dancer is the software framework that TritonGPT is built upon. It was developed by two UC San Diego alumni who went up to Silicon Valley and to seek their fortune. Their company, now called Onyx, produces Dancer as an open source platform that we are utilizing as the underpinnings of TritonGPT. A little bit later, I'll show you all of the additional functionality we have built out around Dancer. But Dancer is in charge of the core search processing within TritonGPT. That's where that RAG process runs. And so the query flow, as you see on the screen here, begins with a little bit of cleanup. This pre-processing would remove formatting, punctuation, also provide a little bit of context about the user, or perhaps about the assistant or the problem that they're trying to solve. We have a job description, helper, fund manager, coach, etc., that we offer to our users. And in all of those cases, there is additional framing that can be put around any question that is asked, if it's being asked in the context of fund management or HR, or if it's just a generic web search or content search. And so that that pre-processed version of the user's query is then sent into a hybrid search system that utilizes the RAG approach to generate a vector. This would be a very high dimensional encoding of the user's query. The model that we're using right now has 1,024 dimensions. If you can imagine a 1,024 dimensional space that is, it's just this cloud, as Matthew was showing earlier. Really, that's trying to locate the query and the meaning and intent behind the user's question within this space of documents that have also been encoded using this model. And so that vector similarity operation that Matthew mentioned earlier is performed. Cosine similarity is one of them. There are a number of other different approaches that are taken. But alongside that, that embedding approach, Dancer also takes advantage of traditional keyword searching. And so this is maybe the sort of searching you might have done before this AI craze started, basically looking at a keyword, standardizing a keyword. So walking would go to walk, etc. And then applying some very well-honed keyword search algorithms as well to the document base. And what we found in cooperation with Dancer and Onyx is that a combination of these approaches really yields the best results. And so the output of those two the functions is then combined, and relevant passages are identified. And then there's a re-ranking step, and that's using yet another model to again compare the user's query against the set of documents that the RAG process identified as being relevant. We want to ensure if the RAG process returns 10 or 15 documents, we want to ensure that we obtain and provide to the language model the top most relevant content for it to consider. So that re-ranking process is crucial, and that's something that's seen quite a bit of tuning and innovation, both from our side and then also from Dancer and Onyx over the last year that we've been working with them. That context, the passages that were identified and ranked, is combined with the user's query, and all of that is handed off to the language model. We use Llama here. We'll get to that in a bit. Open source on-premise model that we run. But this same process would work with ChatGPT, GPT-4, etc. And then the language model is really then charged with answering the user's query based on the provided content. And as Sean was saying earlier, that with that vertical integration, the fact that we can tie together UCSD content and really present to the model instructions to answer a query from the perspective of UC San Diego really helps ensure that the supplied content and the answers are really relevant to our users here on our campus. And that's where the final answer would be supplied back in a chat form to the user. Right, next slide. Right, and as Matthew went through earlier, when we are pulling information into Dancer, and so this would be using connectors that are set up within TritonGPT that will pull data in from websites, from Google Drives, from Atlassian Confluence websites, wikis, many other sources. Dancer supports, I believe, about 50 different content input streams right now. That information is sent through this chunker, and that chunker can be tuned according to the type of data that's coming in. And so it will insert into the vector database paragraphs, pages, sections in a fairly intelligent manner. That chunking approach is also an area that has seen quite a bit of innovation over the last year. And so because Dancer's been keeping atop of those innovations, that's enabled us to similarly roll those out to our customers in a fairly rapid fashion. Another angle that Dancer is allowing us to pursue is use of multiple embedding models. In some cases, that transformation of a document into that vector space may be tuned to a particular area, to a particular type of document or a particular question context. And so recent developments within Dancer are laying the groundwork to support multiple embedding models at one time. And we'll be able to roll those out as we identify opportunities. All right, next slide. All right, and so this is the overall architecture of all the various components that pull together and form TritonGPT. I want to just direct your attention to the center, a little bit above center, the dialogue engine, Onyx. That's the Dancer application that forms the center of TritonGPT. That's handling the user interactions through a user-facing service, the background content indexing and re-indexing, downloading web pages and such. Interactions with the LLM are handled there, and then the sequencing of which RAG queries to perform before a prompt or after a prompt, etc. All of that intelligence is within the Dancer dialogue engine by Onyx. Those application components connect to data stores, vector data stores such as Vespa. That is a very high performance and highly scalable vector database that was originally developed by Yahoo about 15 years ago, but it's been rock solid and used throughout industry for search applications much larger than ours and much larger than TritonGPT. But it has been tuned for speed, tuned for capability, and we know that when the time comes and we do need to scale out, we will be able to. I want to point out that or mention that the application components, the data stores like Vespa and the ancillary databases, Postgres, and some of the other data storage components, all of those are private to each instance of TritonGPT. And so we are in the process of bringing on partners at other universities, beginning to index their content. And in each of those cases, their operations from the web interface all the way through to those background RAG databases are running on completely separate application instances, database instances, and storage environments with strong security between them. And so we want to keep UCSD data private to UCSD, San Diego State, private to San Diego State, et cetera. And that's been kind of a key architectural goal of our build out. Some components off to the right, you'll see large language models. Those are shared between instances. Those are right now include Llama 3.1 and 3.3 just released by Meta. And we're able to run those on premise at our San Diego Supercomputer Center. Just due to the background that UCSD and SDSC have in running machine learning and AI workloads, both in the research and the instruction space. And we're, with the flexibility of Dancer, we're looking at expanding when necessary out to language models such as Granite, Claude, even OpenAI is an option when necessary. All right, and then finally, I just want to say that the data stores that are coming in, I've talked about web pages and Confluence websites and the like. Those are all static data that would be coming into Dancer. There's also the opportunity for dynamic data that would be querying on-premise data warehouses or other sorts of live and real-time information flows. And so for that, I'm going to hand it over to Jack Brzezinski, who's been leading up our efforts in that area.
Thank you, Adam. Next slide, please. So I think that we are kind of looking at several other capabilities that are kind of going beyond text processing. So there's a query, and we are expecting some sort of a textual answer that is driven by the RAG process and the retrieval of relevant embeddings. Obviously, that's very useful. However, here in this diagram, we are kind of showing that well, there is other types of computation that we might be interested in, and that computation might be involving perhaps tasks that are requiring retrieval of structured information from databases, perhaps performing computation on those data structures, and then perhaps visualizing some of the results, which obviously goes far beyond sending and receiving text strings in the RAG basic pipeline. So here we are trying to visualize an architecture that would be essentially agentic. So if there's those connections between the dialogue engine towards the structured knowledge representations, then we need to have agentic architectures that can accomplish that. And it's not maybe so much in terms of finding and retrieving relevant information, but actually performing the computation when there's several options that have to be dealt with. And those options often will be defined by the presence of metadata, right? So there might be smaller or bigger knowledge fragments that we need to be able to interact with so that the question can be answered. Sometimes there is going to be very large chunks, and those can be existing within the RAG architecture, and we will retrieve them as vector embeddings. But sometimes those will be very dedicated metadata techniques that have to be that we know that we don't have to look for them, but we know that we have to have awareness, kind of like a maybe short-term memory idea versus long-term memory within the AI system. Then we would like to be able to have some sort of a knowledge in terms of let's say if this is structured information that we are interested in, what kind of selections need to be made. So the context filtering and various aspects of effective data retrieval from tables kind of comes into play, including perhaps content that needs to be sensitive in terms of security and all those governance aspects. So we are looking at different types of computation that really kind of requires a little bit of different approach. So in the next slide, I'm going to try to maybe outline some of those different approaches. Right. So here we are looking at a possibility where the core interest would be retrieving SQL data. So in an agentic process, we will have to find a way to create SQL in real time that is answering a user question. So what are the agentic keys here that are important? Well, first of all, the order of operation of tool execution can be fixed. So we may know the solution to the problem, and it's going to be procedural. So in terms of an agentic architecture, it's not that interesting in itself. But let's say if we have a collection of tools that are described through their own metadata, then this architecture that we are looking at, the dialogue engine can become also an orchestration engine where the tools will be aligned depending on the type of the question. So perhaps the question is going to be reaching into several column groups that exist within the database. So perhaps the agent will need to execute several tools that will put together the answer from multiple tables. But sometimes perhaps there is going to be only one column group that is going to be in play. So that means that perhaps a smaller piece of the activity hubs that we are looking at the bottom needs to be answered. So this flexibility where the AI can actually find the most appropriate tools as they are described to the system gives us tremendous advantages. So that's kind of an important aspect of agentic architecture. Another important of an agentic architecture is the fact that this dialogue engine that is kind of the heart of the system at the moment can also act as a judge for the quality of an answer. So LLM as a judge is a kind of concept in the agentic generative AI where we are trying to assess whether the answer that came back from the tools is actually appropriate. Is it answering the question? Is it sufficiently detailed and all those things that we can actually control? So again, the activity hubs data can come back through the EDA, our enterprise data agent platform, and we can perhaps look at other tools if, let's say, the answer is insufficient. And if it is, then it's going to be processed and summarized again by a large language model. So, so as you can see, this is kind of a very interesting proposition where we are able to perform a computation that you are looking at, where there's going to be some numeric values that have to be calculated, retrieved, reprocessed, and perhaps visualized. And at the end of the day, the LLM is going to assess whether this is enough to answer a user question. Next slide, please. Yeah, so here's what is possibly going to be the answer that we are envisioning, and this is something that we are currently developing, where the computation is going to happen within the TritonGPT framework. So there could be rich visualizations that are being produced by the code that is generated within the agentic generative process. That code is going to be either used to visualize the data or maybe perform some sort of a statistical reasoning. There is also capabilities for us to create the so-called model tournament, where the answer is going to be comprising of multiple machine learning models that will be triggered by a generative process so that they can answer the question. So perhaps the pie chart that you are looking at is going to be a result of some sort of a multi-model modeling or clustering and whatever is necessary to answer the question. And like I said, this could be a prescribed procedure where the agent basically is following a section of steps, or that process can be basically orchestrated dynamically based on perhaps unknown user query or something that we've never considered to be a viable question. So there is tremendous flexibility here in this architecture. Next slide, please. Yeah, so here I'm trying to maybe lay out a little bit of kind of the kind of code architecture that we are building. So within the LangChain framework that is used very widely in the generative AI industry, we have the capabilities to basically do multiple types of orchestration, right? So we can run our agents, so we can define our agents that will have very rich level of interaction. As you can see here, we are outlining that the input to the agent can be the user query. It could be some sort of a conversational history that might be split into, let's say, primary topics, secondary topics, most recent conversations, or maybe like a long-term memory, like a distant conversations. And the AI can be used to prioritize those. We can also kind of look at what is going to be the appropriate computational little engines or tools that need to be invoked. And again, the thing that I'm including here is maybe something that is really key, which is that the tool can have a very rich description inside the code, which will enable the large language model to actually pick the relevant tool let's say, if it is not prescribed by the system designer. So so here I'm saying, hey, maybe this tool is going to look at some sort of an analytical aspect of the problem, right, where we are looking maybe at a specific column or a specific table. So what you are looking here in the looking at in the diagram is perhaps a sequence of generative tools that will do a retrieval from different perspectives or different aspects depending on what the user question was, right? So so that is kind of the most basic architecture that we can have. So next slide, please. Right. So a little bit more interesting architecture that we can have is that, well, nobody says that there is only one agent that is allowed. So we can imagine, and actually we are building an architecture where there is going to be perhaps an agent that is going to be kind of like a dispatch or main orchestrator that is going to be reacting to user queries. But then some of the user questions may require that there's going to be maybe a specialized computation performed in some other computational platforms or with other dedicated agents. So for example, there could be a machine learning dedicated platform, let's say external computational agent that is basically optimized for running machine learning models within, let's say, HANA, our database platform library, right? So that's a computation that can happen, of course, with tools and with various data resources, but it is something that enables us to basically subdivide problems into really interesting computational chunks. And here, the third aspect that is interesting here in this diagram exists in here, what's happening when the information comes back to the agent, right? And here we are using the large language model as a judge, right? So that architecture here enables us to evaluate whether the model was correct or incorrect. And if the answer was bad, right, maybe we need to rerun different tools, or maybe we need to look at different sequences. But certainly this is something that is really a fully fledged agentic capability. Next slide, please. Right, so here I'm highlighting that capability where now we are kind of looking at this kind of computation where there is not only the user question, and then we are just picking up the tools, right? But then there is feedback that comes back, and that feedback can be quite elaborate. So, for example, we obviously, if let's say we retrieved something using SQL, so there might be a data set that came back, but that's not the only thing that can come back from the tools, right? What can come back is maybe a relevant data set, right? So maybe another data chunk or data fragment is going to come back and constitute the context within the agent reasoning process, right? So maybe I retrieve the data set, but maybe I will also retrieve some sort of a surface statistics, maybe a similar data sets, maybe something that is not exactly answering the user question, but perhaps we know from prior conversations that one way or another that might be an important piece, right? So the tool feedbacks cannot be just the primary answer, but it could be multiple things, right? And then perhaps on the other hand, the tool feedback doesn't have to be like all pretty and kind of the sun is shining. Perhaps the tool realizes, or the process that we orchestrated did not produce a correct result. So we need to have a graceful degradation of the algorithm. So the tools should be able to produce feedback that actually tells us what happened, right? Is the data too sparse? Are we missing maybe something important in our SQL generation process? So all this tool feedback is kind of important, and then it kind of comes back and gets assessed within the agentic framework. So it could be assessed in terms of the relevancy to the question. It can be assessed in terms of the relevancy to other prior conversations. It could be assessed on the fly in terms of the relevancy to the questions, to the question that we've got, right? So one way or another, we have that process where, at the end of the day, right, if everything is good, there's going to be some sort of a summarization or a visualization that is going to happen prior to delivery to the user, and everything is okay. And if not, there's going to be some sort of information presented that is going to be also useful, in different setups. So here, right, really kind of it's a complex kind of memory processing with various levels of metadata being in play. So yeah, next slide, please. Right, so this is maybe a little bit deeper drilling into fact retrieval. So here I'm outlining the specific tools and procedures that are kind of in play here. So the agent is kind of looking at processing with several kind of chunks or modules that are important to us, right? So there's the user question that needs to be processed. So perhaps, kind of traversing to the right, we are expanding what the user really meant. We are trying to look at metadata that is relevant to the user question, right? So we are kind of, moving to the right and kind of moving towards the data sources, right? But then there is also other things that kind of are important when answering a question about, fact retrieval. So really answering a question about, maybe business intelligence kind of style of a question. Right, so we would like to kind of look at, well, what do we know about the question? What can we attach to the answer? Not necessarily in terms of the RAG, because RAG is really powerful when we have a lot of data points and we are required to execute search. But there's going to be other architectures in which we don't have to look for things because we know what is necessary. We know the data chunks that are necessary to be attached, right? So that's another piece. Another piece that is important is that obviously metadata about the schema of the database and all those things. So at the end of the day, there's several steps that those boxes represent. And like I said, those could be procedurally kind of aligned here, or those could be essentially picked and chosen by the agentic process, depending on what the question will be, right? Maybe I don't need metadata because it was a very basic question. Maybe I don't need prior conversation knowledge because really this is something that is kind of a slam and dunk. Or maybe I need all those modules to really think about the answer. So yeah, that's kind of a little bit closer to the code that we are developing for our fact retrieval processes. Next slide, please. Right, and this is kind of another version of agentic process where we might be looking at document review or contract review, where the problem is a little bit different. We basically are trying to edit a legal document based on existing examples of what is acceptable to our legal departments, so that the NDA or some other legal documents can be accepted or edited appropriately, right? So in this particular example, we are not necessarily interested in database retrieval, but we are very interested in very highly nuanced matching of patterns of something that is correctly annotated by legal specialists, legal professionals, and then matching those examples against the incoming NDA documents and discovering whether there is any necessary edits that can be applied, right? So in this particular process, we are focusing on building a system that can use those data fragments about specific problems. Let's say, well, is the name of the university correctly represented in the NDA, right? Is the address correctly represented, right? And those are very kind of like a surface patterns that are very easy to spot. But then there is going to be other patterns, like for example, is there appropriate references to confidentiality in the document, right? And confidentiality may mean at least 10 or 15 different things. Like for example, are there appropriate confidentiality measures spelled out? Or maybe whether there is something that says that the document itself is confidential, which UC San Diego is not allowing, as appropriate language. So there could be a very highly nuanced passages or clauses in the examples that have to be appropriately applied to new documents and then kind of handled appropriately. And as you can see, the outcome of the process is a so-called red line, where we are highlighting the deleted part and the AI is producing an appropriate wording with a comment that is explaining the reasons for changing an appropriate legal basis and all those things. So that's another kind of process where we are implementing generative AI driven document review. And I think this is probably my last slide.
Yes, so I am back. Sean here again. Just wanted to highlight some of the assistants that we actually have out in TritonGPT currently that are available to any UC San Diego staff and faculty who are not part of our clinical operations, but these are currently out there and available. These assistants are built on that RAG infrastructure that we learned about today, and mostly geared towards specific use cases. So as we get more use cases, we're of course building out additional capabilities and functionality within the tool, but also different assistants that'll help out with different tasks and things you might do on the day-to-day at UC San Diego. You'll see at the top, there's quite a few other assistants in development and are testing, things like policy assistants, data dictionary assistants, and this kind of scrapes the surface. It's a bit of an iceberg. There's a lot more that we're working on and are in different phases as well that are coming soon. Which brings me to my next slide. Additional in-progress functionality. So these are things that we are working on. We're developing as core functionality of the TritonGPT platform and will be out in the future. Internet search is coming very, very soon with the next release. We're constantly doing releases to the platform. So internet search is going to be a new assistant available where you can use a large language model. So again, these large language models that are trained and have a certain end date of the training data that they have, but this one's now connected to the internet, so it'll be able to bring back current and relevant real-time information. Fact retrieval, that's what Jack had went over, as well as contract reviewer. So these are going to let us, one, just natural language query a TritonGPT and get data from our own activity hubs back as part of those answers. And then contract reviewer is kind of a special use case, but you'll be able to put initial contracts in and get a red line version out that our contract negotiators will then be able to go through, confirm everything looks good, and start working with the external partners. Student access is a big one. There are a lot of different checkboxes that need to get done before we would open this up to students. So there's a lot of work going on behind the scenes to eventually open up the platform to students and some of the additional use cases that'll bring along with it. And then at some point in the future as well, there will probably be an assistant builder capabilities and an assistant store. We're working through all the different guardrails and how we would make that available and what it would look like in the training. But the idea is that it'll allow scalability for assistant creation for a lot of these use cases and externalize it to some extent. So kind of exciting new things on the horizon that are currently in progress. We're working on different pieces of each one of these, and they will be on the future roadmap. Next slide, please. So just a quick recap. Biggest one, no data leaves UC San Diego infrastructure. Very protected, everything stays on premise. Nothing's going outside of our walls, overseas to any of these other companies that could be doing different things with our data. Our data is not used to train large language models as part of that. We don't even train our own large language models on any of the data that would be put into TritonGPT as part of prompts. TritonGPT is LLM agnostic. So you'll see in the architecture diagram, there's quite a few different models that we had put in there. We use different models for different things. We could switch models out by assistant on the platform. So we are not tied into any large language model. Llama just happens to be a really good one that we've been very happy with. I'm excited to switch over to Llama 3.3 that was just released last week. The architecture is designed to be flexible and modular. This is very important. Things change in the AI world every day. We have a daily stand-up with our internal team, and it's like every morning we're like, oh, did you see this new thing? Did you see this cool feature that was released? Or here's some cool concepts that are going on. So we're constantly staying up to date and informing each other and diving into things. As you could tell, we really love this stuff, so it comes easy, but we want a architecture to our solution that we're building where we can quickly swap out different pieces. So I know when you saw that architecture design, there was all kinds of different pieces on that page, and they're all very modular, so we could swap them out as needed and offer the best kind of performance to UC San Diego that's possible. Agents and tool calls is really a new frontier that we're very excited about. It's going to allow addition of a lot of different features and functionality to the TritonGPT platform, some outside of just what you would get from what has historically been the assistant experience. So next slide, please. Just to summarize this all up. Of course, I had TritonGPT give me this summary as I fed it bullet points from the other side. But TritonGPT is a dynamic platform designed to evolve alongside a rapidly advancing AI landscape, powering UC San Diego to achieve its goal of continuous improvement through adaptability, innovation, and rapid development of new features and tools. So really sticking to the core continuous improvement mindset that we love to foster and be a part of here at UC San Diego. Next slide. So how can you participate? One of the best ways to do this is go out, use TritonGPT. It is there, it is available. I know we love talking about different use cases within the internal team. There's several different communities and ways to participate in different use cases. All kinds of cool stuff comes out. We'll say, oh, look at what I tried to do with TritonGPT and it did this thing awesome. I fed in, certain feedback and career goals and put my job card in as a file upload. And then it really had some awesome kind of external and responses for me that really relate to what I do and ways I could use it to help me further what I do just by feeding our own job card. So kind of one cool use case. There's a lot of different things out there. But as you're using it, you have the ability to upvote, downvote. We really love feedback. It really helps us go out and improve the product. And sometimes, as we described the RAG architecture, there might be content that's being ingested into our index and our database that might not be the most updated, right? I know all the content owners on campus try their best to keep everything updated, but it's not always easy. It's not always possible. So when we get feedback that some of the core content coming into the infrastructure might be a little out of date, we will de-anonymize or we will anonymize that information and have our content team work on that and get updated information. Things are updated externally on websites and different areas that we bring in. That's instantly updated within 24 hours on the platform, and you're getting new answers and correct answers. There are other ways to get involved. We talk about some of the use cases and additional use cases that are being built out. So with that, I'll turn it over to Laura, who could talk about our AI use work group.
Thanks, Sean. So I'm Laura Pradenas. I am the Chief of Staff to our Vice Chancellor CFO, And I'm also the co-chair of the AI and admin work group. So I'm just going to share some more information about how we approach governance and idea review at UC San Diego. And you can see on the slide that, when we realized AI is here and it's rapidly becoming part of our processes, and our community is using it, right? And it's just going to continue to do that further and further. We really formed this group so that we could think about this new technology and consider the risks, consider the benefits. We're going to talk about the challenges that we need to consider when we're using these tools. And then obviously we were unique in that we could further discuss how we would want to build out assistance in TritonGPT, because we had that platform as well. The work group is really focused on kind of building the awareness of UC San Diego's AI-related strategies, because we really know that people are using them, but we want people to understand how to use them safely. We want people to understand what we're planning to build and create. And we also wanted it to serve as a two-way street. So we have representatives from across the university. Each vice chancellor area has a representative in the group. And it's really meant so that we can share information with them about what's going on and what's planned next, and they can share it out with the campus community in their area and their constituents. We really hope that they're out promoting and talking about the AI guidelines that we have in place, and just safe ways to use these tools, but also being very encouraging of people using them and putting them into their work processes. You can see, I'll just run through quickly. As I mentioned, I am the co-chair. Mojgan Amini has been a wonderful co-chair for the last year. In the new year, I'm excited to welcome Dan Suki, from our ITS team, who's going to join me in co-chairing the committee. We are sponsored by the CFO and our CIO, Vince Kellen. And as I mentioned, we have about 20 participants, each representing the different vice chancellor areas and other key areas of the campus that need to be present. And we report up into our Enterprise Information Services Committee. So really being able to share with them what we're doing, how we're doing it, what's coming up next. And we meet about every other month, which for right now, there's more than enough to talk about in every meeting. And some of the things that we're looking at are these lists of AI initiatives and the AI ideas that are coming in. And we're just showcasing and talking about the different approaches and the outcomes. And as you can see on this slide, so when one of the representatives in the committee submits an idea, we have our IT group and our team in OSI, which is the Office of Operational Strategic Initiatives. They function as an internal consulting group. They partner with the business and they figure out, what additional inputs needed to look at the idea and present an example of all the different criteria and kind of assess it in sort of a business case. So we're looking at all these different criteria, which I'll show you next. But really, when the committee looks at it, the committee is looking for, is this idea going to impact the whole university? Is it going to support our creative ways that people are doing AI? And then the work group prioritizes it. It might go to proof of concept. It might go to project. It just depends on the particular idea. Next slide. And this is just an example of the type of data we would share. You can see the process overview. You can see we look at considerations of different AI solutions, and then desirability, viability, and feasibility. And I think that's it for me. I'll turn it over to Stephen to talk about resources.
Thanks, Alora. Perfect. So we just have a couple of slides left. Thank you all for sticking around. We're at 61 minutes out of 60, so we're looking right on schedule. We wanted to kind of highlight the resources page. If you all search tgpt.ucc.edu into your web browsers, whether you're a UCSD employee or not, you can actually see the TritonGPT resources and training page. You can also see in the top left there in the navigator, you can also see release notes. So a lot of the stuff that Sean and Jack, Matthew and Adam were talking through were in development, and when they do get released, they'll be added to the release notes on the side there. But we really wanted to also push some of the wonderful resources that ITS and OSI have been developing. These webinars included, as you can see at the bottom. And for those who haven't taken it yet, we have 2 asynchronous courses. The first one's kind of platform agnostic, kind of showing people kind of the basics of using tools like ChatGPT and TritonGPT. There's a version that is available for the general public, and there's also another version of that that's available for UCSD staff. And then there is kind of a part 2 to that, which focuses specifically on TritonGPT. OSI's Tony Nava worked on those, and he's a wonderful educator and a great trainer. So it's really well worth checking out if you hadn't yet. And so I believe, actually, speaking of Tony, I'm going to hand it off to Tony to talk about our next webinar.
Yeah, so as mentioned, if you want to share this webinar or look at the previous ones or share them out, the videos are available there as well as the slide deck. So upcoming, what we want to do in January is we're thinking of doing a prompting session. And what I mean by that is, some of this one was very technical. It let people know kind of what the structures are and all that stuff. And some of the previous webinars were about the different assistants or about different applications that people have maybe used in their work situations. Now I'm kind of thinking that this one in January is going to be an opportunity for folks who are in attendance to not just hear us talking at you a whole bunch of content, which is all really, really useful. I think it's going to take us, it's going to kick it up a notch a little bit if I can get hands on keyboards and if people can really start trying this out. So I'm really excited about launching that. What we're likely to do is have a couple of different time frames. So if you're not able to make one time block, we can do another. Folks will be able to be ready with whichever AI tool you want. So if you're at UC San Diego, we strongly encourage you to use TritonGPT. But if you're not at UC San Diego, if you have another a tool that your institution's using, or if you just want to practice in ChatGPT or some other tool, it's totally okay. We're going to share some prompting tips and some different things that we found really useful. We're going to give you a couple challenges. We're going to put you maybe in breakout rooms and see if you can do some things as groups. We're really, really excited what that could look like. So feel free to register for that once it's posted. Again, it'll be on that same TritonGPT registration resources page there with the other webinars. So yeah, looking forward to it.
Thank you, Tony. And now we've reached the part of the session where we're going to answer some questions. So if the panelists, if you can put your camera back on. And for those in attendance, if you do have any questions, please put them into the Q&A box, and so we can get those answered. And I think to start off, Jack, we had a question for you. When we were talking about the kind of features of LLM as a judge, there was kind of a section in there where there was another LLM or a different kind of part of the application that was, judging the quality of the answer. What is it looking for when it's trying to do that?
Yeah, so it's kind of it's kind of amazing every time I work with those agents. So first of all, when you are running an agentic generative agentic process, you can look at the internal dialogue of those tools and those agents. So an agent might basically kind of have a dialogue with the tool, say, hey, I'm doing, XYZ, and then, whatever comes back from an agent is kind of annotated, and it's kind of, it almost looks like a panel of experts working on the problem. So, but then when the process is ending, you can have control over what the quality is. So this may look in a number of different ways that can be done. So, for example, let's say there is a fund manager, and the fund manager is looking for maybe direct costs for award XYZ, right? So they will. They will enter a number, and then the system is going to work on kind of the relevant data, and it's going to produce a number. Let's say this number is a 0, right? It's very easy to detect for the AI that, well, that's probably not a good answer, because nobody would look for to have an answer like that, right? So then then there's a possibility now to improve an answer, and in that particular context, perhaps there needs to be a date adjustment, right? Because maybe the SQL query was looking to a very narrow period of time, and really there was nothing entered in the cost column. So it will maybe increase the range, right? And that knowledge should exist in the metadata, right? Like there should be some sort of a knowledge fragment that is going to inform the AI that, hey, this is kind of like the time range is an important thing. Now, there's other things that we can do if we have sophisticated knowledge fragments in play. For example, we might have a statistical model of the direct cost, right? So if the number comes back and it's very far, let's say from the average or from whatever the distribution model might be, then the AI might say, well, this number really is not looking too good because historically, there is a range of numbers and this falls outside, right? So again, you have a lot of as long as you have the knowledge fragments available, you have a lot of latitude in terms of how do you steer the system, like are you rerunning the process with some different parameters, or do you provide this information to the user and then the user is going to make a decision what to do next? So there's quite a bit of capabilities there that are resulting from the fact that those agents have an internal dialogue, and the large language model can actually look at this internal dialogue and evaluate it pretty much a human expert would.
Thanks, Jack. A couple of follow-up questions for you. In your kind of test so far, how many does this process end up going through like different like multiple loops? So does it, hey, this answer's bad, it goes through, the answer's still bad, it goes through. And I guess a follow-up to that is, what does that look like for the user? Does that mean, when we're using this model, this kind of, method, things are going to take a little bit longer?
Yeah, so obviously, the computational cost is rather significant, right? So we don't want the users to wait an extended period of time. So there's obviously things that we can do in the foreground, and there's things that we can do in the background, right? So this can be orchestrated in a way that there could be some intermediate answer coming to the user right away, and then the background processes are still kind of resolving some of the deeper issues, right? So yeah, so to answer, this is kind of very highly depending. The question is very highly dependent on what we are looking at, but yes, we are aware of the computational cost, and we definitely don't want the user to wait, a long time for an answer, unless, right, this is kind of from the get-go. For example, in contract review, right, and from the get-go, we might assume that this is not going to be a real-time answer because there's simply too much computation involved.
Yeah. So thank you. We do have one question in the Q&A box. Christian's asking, what sort of guardrails are used in the system? And I'm assuming we're kind of looking at kind of a safety aspect.
Yeah, I could take that one. So one of the biggest kind of safety aspects of the system is like we talked about here, nothing leaves UC San Diego. It stays within our own internal infrastructure. Nothing's going out to any of these other companies or organizations. So that is one of the biggest benefits. We're running our own locally hosted large language models. A lot of things have been in the news recently, and we're always watching and trying to follow along, and that's one big guardrail that we have that's just innate as part of having TritonGPT on campus. In terms of safety and functionality as well, there's a lot of testing that we do internally. I know in the architecture portion, we talked about wanting to go from what we currently are using as our primary model, Llama 3.1, to Llama 3.3. We had Llama 3.3 stood up and in our subprod and testing environments ready for use within the day that it was released. That has been kind of our roadmap. And we do a lot of safety testing and prompting and different ways that we test it out. I could bring Jack in to talk a little bit about how we do that in some of our ensemble of expert approaches and some of the really kind of fancy things that have been done to do some of this testing.
Yeah, so the safety issues are hard because the conversation with the model is a highly unstructured process, right? And it kind of is a dialogue that can have many different contexts. So what we are envisioning is obviously one aspect is relying on the internal safety of the model quite a bit, because llamas are quite good at not willing to make a conversation about questionable, maybe harmful content. But then on the other hand, there needs to be specific guardrails that we are defining as a kind of multidimensional problem, and this multidimensional space is defined by kind of leading research in the AI safety field. So, for example, maybe controlled substances is one guardrail that needs to be monitored, and all the other things. So we have identified at least 10 dimensions where there might be a questionable interaction, and we are building an ensemble of models that kind of provide a voting mechanism, right? So we understand that different models might have different priorities and different kind of views on certain topics. So we apply more than one so that we can actually look at their votes and their justifications for the votes and kind of accordingly filter the content that might be harmful.
Oh, yeah. And Christian, if you have any more that you would like us to dive in on that, feel free to add some more content in there.
I think, Tony, you had a question, right?
I mean, I'm thinking about, how fortunate we are, right, at UC San Diego to have the supercomputer center and that sort of thing. And I was wondering if somebody could speak to partnerships we have with other campuses or anything like that.
Yeah, absolutely. I could take that one. So I talked about how our architecture is built so modular, and a big portion of that modular architecture is looking for open source capabilities and ways that we could really keep the cost down. The idea of keeping the cost down, as Tony had put in the chat, any faculty and staff from UC San Diego, right? We have a large group that has access currently to TritonGPT at no charge to the UC San Diego community. So we're really trying to keep that cost down and, make AI and different functionality that we could build around AI available as widely as we can. That also can look like partnering with other institutions outside of just UC San Diego. We actually have some use cases that are exactly that, where we've partnered with SDSU, and we've also partnered with our friends up north in UC Berkeley to offer clones of TritonGPT for them as well. This comes at a very low cost when you start looking at other options. OpenAI is a big one that's out there, right? There's a lot of use. Licensing and all the pieces that come along with that is usually a lot pricier than what we could do within the infrastructure of TritonGPT, and that's a big portion of why we've put so much effort to keep those costs down. So there is ability to partner with other institutions, and a big part of it is, making it available to everybody, right? It's a great new functionality. It's a new frontier of things that we could make ourselves, right? Back to the continuous improvement across UC San Diego, and the more we're able to utilize the newfound functionality of AI, and then we're able to add that value back to our core mission with students and research and faculty, and we could spend less time composing and working on wordsmithing of email, and we could quickly do that with a tool like TritonGPT and a lot of other functionality within day-to-day work, and then we could take that saved time and put that back into the more value-added areas. So we are partnering with other schools, and we're open to do that, and that's kind of why to give that back to allowing people to focus back on the core missions of higher education.
Thank you. And there's one in the chat here. Is there a place to find out more? Can you speak at a high level about the hardware of the platform currently?
Yeah, I know Adam touched a bit on the hardware. It is all locally hosted at San Diego Supercomputer. It's hard. Sorry, I don't want to go too much into it. Adam, I'll turn it over to you on that one.
Yeah, okay, thanks, Sean. So at the Supercomputer Center, we have 4 hardware, physical servers sourced from various manufacturers, but Dell, I would say, prominently among them, with modern NVIDIA H100 GPU cards. And those servers handle the bulk of our large language model operations, also handling some of that embedding work in the RAG process. And then beyond that, we're relying on existing infrastructure that we maintain for either our data science machine learning operations or for administrative IT within systems that are also hosted at San Diego Supercomputer Center. And I'd be happy to send out or attach to the notes for this call a little bit more detail on specifically what that is.
Awesome, thank you.
Thank you, Adam. All right, I'm going to do one last call for our participants to, for those on the call to put your questions either in the chat or in the Q&A. Don't make Tony tell a dad joke. He's got his cards out in front of him. I can tell his camera's off, but
I don't have any dad jokes, but I can tell you about my border collie. I got him because the one I had wasn't bored enough.
Thank you, Tony. I don't see anything else in the chat. So with that, I'm going to thank you all for coming. Thank you all for staying. Hope you learned a little bit. I definitely learned a little bit as well about the great work that our IT services are doing at UC San Diego. And again, we'll send a follow-up to everyone who registered with a recording of link to the recording as well as slides. So again, thank you for joining us today and have a wonderful rest of your week. Take care.